You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this. Hey everyone, welcome to this week's show. Excited to have the whole gang here together. How we doing?
So great.
Good to be here.
It's warm, Kirk. It's warm. But otherwise,
sure has been.
But otherwise, doing great.
A little melty. I did stop and buy some ice cream today just to have on hand.
I'm not gonna lie. I don't think I mentioned this, but like when I was dog sitting for you, Kirk, while I was around and in your house, I did get ice cream every single day that week.
Wow.
Which is a lot of ice cream and was not planned. Some of it was at work. I will say that. Some of it was like work provided. Yeah. But I did get a lot of ice cream. And
there are some very good ice cream places
right next to your house. So. Yeah. So worth it.
You left the frozen Northland, Rachel, and you have to deal with the
heat. Yeah.
Weather here in the tropics of the Twin Cities.
The tropics of the 45th parallel. Yeah.
Right? Oh, God.
Well, ice cream and heat aside, this week I want to introduce you to an insect, and it is the Bogong Moth.
So the what?
Bogong?
Bogong.
Is it
Bogong? I think that's how you say it.
Okay. Because it could be the Gugong moth.
Nope, that'd be something totally different. I think I do have a can of Gugong, or probably Goof Off somewhere around in here. But anyways, these cool little creatures hail to us from where else? Australia.
Oh,
yeah.
I wasn't clear when I first heard about this, whether this was like an obscure creature or one that our Australian listeners would have heard of.
Yeah.
Apparently, there are around 22,000 species of moths in Australia alone.
Oh,
and I wouldn't really expect people there to be familiar with just one species. However, I may have been wrong about that. Digging a little deeper, the Bogong moth is pretty culturally important. These moths undertake huge seasonal migrations, similar to how monarch butterflies famously migrate through North America. These moths spend the autumn and winter in southern Queensland, western New South Wales, western Victoria, and also in south and western Australia. They then migrate either east or south to mountains for the spring.
Oh, okay.
So it's not necessarily like it has to be a particular direction. It's more like head toward wherever the mountains are, it sounds like.
Head up.
Right.
They can migrate up to 600 miles or about 1,000 kilometers.
That's pretty good.
That's
not insignificant for an insect.
Absolutely not. Now, I will say for comparison, if you're wondering, the monarch, depending on where they start off, can migrate between 1,200 and 3,000 miles. A lot further, but this is still a very respectable distance. Now, I did note that they head to the mountains, and one notable mountain they come to is Mount Bogong. And there are other parts of other mountains that are named after these moths as well. And it seems like a pretty appropriate name for the mountain if that's where they're headed.
I mean,
what is really interesting is that they're gathering in huge groups for estivation. And I don't know if that's a word we've ever used.
I don't think it is. I'm not going to lie. You said that, and I'm like, I think from context, I know what that is, but I don't think I know what that word means.
You can think of estivation as like a summertime hibernation for insects.
Okay, that is not what I thought it was at all, so I'm glad you explained what that word meant.
I think we often associate some period of dormancy for most living creatures as being a wintertime thing, right?
Yeah.
But these animals, it's a summertime thing, probably because it gets too hot.
I was about to be like, does it have to do with the temperature? Because
probably trying to avoid the some of the extreme heat.
Because going higher elevation definitely does cool you down.
Yeah, they can't go get ice cream like we were just talking about. They have to estivate, and that's AESTIVATION, estivation. So they prefer to estivate in caves if they can find them. They'll also use like hollowed out trees and stuff like that. But caves are the best spot because it's again cooler. And these moths basically just like in these huge groups, and they shut down for the whole summer. The kind of metabolic processes slow down and everything, and they're basically kind of in stasis, which is very, very cool. I did mention that they can gather in huge numbers. And you can imagine when large numbers of animals gather in one spot and don't move, they can quickly become a food source.
Sounds like snack time.
Yeah, and well, I'm glad you're hungry, Rachel, because in this case, they became a snack food for humans.
Okay, sure.
Yeah, so...
I've eaten insects before. Let's go.
Yeah, the Aboriginal residents of Australia have traditionally gathered where the moths estivate to feast on them because it's a really great food source. And this is also because people were coming together. This is where intertribal gatherings would also take place coincident with these feasts. So as I said, culturally, this is a really important insect, which is why some people of our Australian listeners may be familiar with it.
Okay.
And incidentally, since some of you will be curious, apparently they have a nice nutty flavor, which is nice to hear.
Okay. All right.
Now, sadly, due to droughts and climate change heating up the caves they use for estivation, their numbers are sharply declining, and they are now considered an endangered species. So, that's frustrating from ecological and cultural reasons, obviously.
Yeah.
Now, there's an interesting question that comes up when the topic of migration arises. And that is, of course, how do animals know where to go? Yeah. And much like the monarch, the moths are making the migration to a place they have never been to before.
What?
Yeah. Right? Because it's like, it was the generations before them that left this place.
Right.
They weren't born there. So they're going somewhere they've never been.
Right.
So not only do they...
We didn't even hear about this from our grandparents, but I got a urge to go see Mexico.
Yeah.
Right.
And I got to know which way to go. Or the monarchs, it's like their great-great-great-great-grandparents or something like that. It's crazy. So the question is, how do they know where to go? And back in 2022, we recorded episode 85, which was called Putting 3D Glasses on Cuttlefish. The title was based on a story, I believe, by you, Rachel.
Yeah, it was.
But my topic for that episode was about dung beetles.
Why?
Real exciting.
Hold on. Okay, I'm following the thread, I think. Maybe. Keep going.
All right, well, the new thing we had learned was that dung beetles are capable of using the night sky to navigate around their local area. So specifically, research showed that the dung beetles use the Milky Way to navigate. But critically, dung beetles don't migrate. They were just using it almost like a local landmark that was really high up that they could see. So like, I know I walked this way for this long and the sky looked like that. Now I can turn and go this way and get back to where I started, basically. So what researchers have now shown is that the Bogong Moth uses the same technique, essentially looking at the Milky Way, not to move around locally, but rather to undertake long-distance seasonal migration.
How do they know?
Now, that's so cool.
Well, this is a big deal because this is the first time research has ever shown a non-vertebrate species using the night sky for migration navigation.
That's so cool.
Yeah, that is really cool.
Very cool. This research was published in the June edition of the journal Nature, so the big journal, under the title Bogong Moths Use a Stellar Compass for Long Distance Navigation at Night. And one of the things I found pretty wild about this research is that scientists apparently already knew that these moths could sense the magnetic field of the Earth to aid in direction finding. So they had to rule that out when they did their studies.
Yeah.
So how do you they had to basically come up with a way to nullify the magnetic field of the Earth so the moths could not detect it. Otherwise, that would ruin their data.
Yeah.
They basically well, go ahead.
Yeah, well, yes, you're right, Victoria. They basically put them inside of like this giant or good size. They called it an arena. I don't know how big it was exactly. But it was, I don't think it was very big. They basically it was like a dome where they could still see the night sky, and they actually I think they harnessed them up or kind of tied them to little leashes so they could fly, but they couldn't get away. And they were studying what direction they were taking off to try to fly. Very similar to how we study this with birds. But they had them in some sort of case that's somehow kind of nullified the magnetic field of the Earth. I don't quite understand the science on that part. Very cool. But it's just astounding. And I think this is one theme I hit on again and again in the show, and that's just how resourceful and clever researchers need to be in order to rule out confounding variables in their research. They had to figure this, figure that this would be a problem, and then figure out how to get around that so that they knew that the results they got were based on what the insects were seeing and not what they were maybe feeling in terms of the magnetic field of the Earth. Bravo. Wow. Very, very cool. But there's more. Because this research went one step further, and this blew my mind. How often do we say that animals do something like migration based on instinct? And I'm doing scare quotes with my fingers there. Instinct, right? And I have always had an aversion to that term because it feels like such a cop-out to me. You might as well just say...
What does instinct mean?
You're right. It's a mystery, right? The word instinct is often just a placeholder for the phrase, we don't really know, right? It's it's instinct. Well, we know they can do it. We're not really sure how it works. Now, it is a bit more than that, to be fair. We know that there is some innate property to the animal that makes it, possible, that makes it behave a certain way, but we don't always understand what that innate property is. We've gained knowledge, and we know that, now that these animals can navigate by the stars, but how? Right? Every time we get an answer to a question like this, we get more questions. Okay, so how do they migrate? Well, they're looking at the stars. Oh, specifically the Milky Way. Okay, cool. How do they do that? Well, I don't know. I mean, we are highly intelligent creatures, and we can, with very complicated brains, and we can learn to use the stars for navigation. But this isn't a taught behavior. These animals are born knowing how to navigate by looking at the night sky. So how on earth is that information encoded and then genetically passed along through generations? Well, this research looked at that a little bit. This particular sentence in the journal article really got my attention. It said, quote, "We showed that visual interneurons in the moth's brain are tuned to specific orientations of the night sky, suggesting their involvement in a stellar compass network." So you can read all the details. This is an open access journal, so you can read all about it. But what they basically did is they hooked up the brain of the insect to instruments to record when neurons were either stimulated or inhibited while looking at images of the night sky. And they seem to show that neurons form a kind of map in the brain of the insect, and they light up when the sky is correctly oriented to the way that they want to fly. So obviously I'm simplifying this a bit here, but this is absolutely incredible research.
That's amazing.
Wow.
We don't have to just shrug and say instinct. We're literally starting to be able to actually see how the night sky is directly encoded into the structure of the brains of these moths. And that structure is passed down through generations. So as the authors note, there is way more research to be done on this topic. And they were only able to sample a limited number of neurons in the brain as a proof of concept, but utterly fascinating. And there surely will be more research of this nature coming out in the future as we sort of figure out exactly how these sort of instincts are mapped in animals' brains. So that just blew my mind. So cool. If you want to learn more, you can read the article in Nature. I will also note, as far as background information here, I got some background information from the Commonwealth Scientific and Industrial Research Organization, which is Australia's national science agency. So very cool. The Bogong Moth. Yeah, they're really awesome.
Wow.
That's amazing.
That's so cool. Thank you for sharing, Kirk.
Absolutely.
Thank you.
Yeah, let's take a break. And when we come back, Rachel will have even more strange nature for us. See you soon.
Welcome back to the show, everyone. I hope you had a good break. I was figuring out what my topic would be for this particular week. And I looked back at our most recent topics.
Yeah.
And I looked back at my topic specifically. But I looked at all of them. And I realized it has been 10 episodes since I've talked about the ocean.
Oh.
So I need to go back to the
Australia.
episode.
It was one of the two.
Yep.
I covered Australia.
That's been more recent. I haven't talked about the ocean in 10 episodes. And there's always so many weird things,
Rachel.
Isn't it? Well, think about it. That's 10 weeks that I have not talked about the ocean.
Yeah.
So, right? So I immediately was like, well, what do I have on my list that has to do with the ocean? So let's talk about one of the most primitive. It is, Kirk, you're going to hate this. It is technically known as a living fossil. I know you hate that word.
No, I like that phrase. I'm fine with that phrase.
Somebody doesn't like it that we know. Let's talk about the truly astounding six-gill sharks.
Oh, okay.
Six-gill?
Six-gill
shark.
Oh, six-gill. Oh, that makes more sense.
Yeah.
It's like sharks don't have scales.
No, they don't. They have very specialized skin. Anyway, so specifically I'm going to be talking about the Bluntnose Six-gilled Shark. There are 3 different species of six-gilled shark. They are most related to dogfish as well as the Greenland shark, which we have talked about but in a previous episode. But what's really fascinating, as their name suggests, is the fact that they have 6 gills. So sharks first showed up in like the barest part of like, hey, this could be a shark in the fossil record about 450 million years ago.
That's right.
Okay?
Older than trees.
Okay.
Older than trees. So because of that, obviously they've had a lot of time to evolve. That being said, the six-gill sharks have not changed in 200 million years.
Oh.
Whoa.
Mm-hmm.
Okay.
Yeah.
As far as we know.
Living fossil bit.
As far as we can tell, yes.
Yeah.
So they are
no major changes.
No major changes. Some of those things that like they're extinct relatives in this group of six-gill sharks date back 200 million years. So that's pretty impressive. So six-gill sharks are really interesting because most sharks only have 5 pairs of gills on either side of their body. So that's one thing that makes it different is they have an extra gill slit. So one thing that is also different is that they have one dorsal fin, and it's actually closer to their tail. They don't have that stereotypical dorsal fin that you think of, like with jaws and everything, the shark fin. This is much further back, closer to their tail. They have a pretty blunt face, and their eyes actually, when they are still alive and such, actually look green, which is really fascinating. And makes sense when you find out that these sharks in particular live pretty deep in the ocean. So they need to be able to see more red light. They can be found pretty darn deep in the ocean. And they actually come back up as well. So they don't just stay in the deep ocean. They are known as they can be found 700 meters in the ocean. They can be found a little bit deeper than that as well. They've been found as shallow as 20 to 40 meters deep in the ocean, but they've also generally will be found much further down. They are known as a deep sea shark more than anything else. So they don't tend to be pretty close to the top very often. And because they are a deep sea shark, they tend to they're not super duper well studied.
Yeah.
That being said, they can be found along the coastal edges of things. They hang around the continents. They're not necessarily found they're not found in the deep Marianas Trench is not that far down.
They don't range the open ocean as much.
They don't go into the open ocean.
Gotcha.
So that being said, the fact that they can disperse themselves from deep in the ocean up to more shallower spaces in the ocean is pretty cool. That isn't a general thing that sharks can do, because the general depth that they have been found is anywhere from 180 to 1,100 meters from the ocean. Okay. Which is a pretty big range. So in American,
from
that's
the ocean
500.
Surface, you mean?
Yeah, from the surface. So that's anywhere from 590 to 3,610 feet. However, they have been found as deep as 2,500 meters or 8,200 feet.
Pretty deep.
Pretty deep. So, but they aren't open ocean animals. So it's pretty cool. What we do know about them, generally they're still this gray, brown, tan. They have a lateral line. They have green eyes. They just kind of look like a typical shark. They don't have, except for the one fin, the one dorsal fin that's pretty far back, and the 6 gill slits, which is pretty unusual. Oh, Kirk is leaning in, being like, "Why are you talking about this?"
Right? I'm like, "There's gotta be more."
That's cool and all.
I'm giving
you this the evil eye here of you are hiding something from us, Rachel.
Yeah. So we've talked about in the past. We've talked about how sharks can live for a decent amount of time, and these guys take some time to become sexually mature and can live up to 80 years. And in that time, the females... So the females are, they are what is known as ovoviviparous, which means that the female sharks, instead of laying eggs and letting the pups, which are what baby sharks are known as, they, instead of laying those eggs and just letting them be, the females...
Which would be oviparous.
The females have their eggs, and they are internally fertilized, and then they will hatch inside of the female shark, and the shark will then give live birth. Okay?
Yes.
Which is pretty impressive. They still have a yolk sac and things like that. Now, here's the thing.
Okay.
These females, and these sharks are large, okay? They're some of the larger sharks. They can get up to be 18 feet long, all right?
Oh, all right.
Right? So they're a pretty big shark.
Yeah.
The litters, y'all. She can have, in one litter, anywhere from 22 pups to 108.
Oh. Wow.
That's a
lot of babies to be carrying and birthing all at once.
Okay.
You know what makes it worse?
No, I don't.
Well, the gestation period for these sharks, we still don't 100% know. But based on other sharks in this genus, like frilled sharks,
okay,
probably gestation is 2 years.
Oh, that's wild.
So you have 100 pups inside of you growing for 2 years.
Do you know how long they're in the eggs? Like, do they hatch out of the eggs and then immediately are like they give birth, or is it like they are in the eggs, they hatch out, and then they're inside for another year before they come out?
That is something that we don't know.
Okay.
Just because it is generally what it looks like, and from what I understand is they are receiving nourishment from the yolk sac while they are still inside. They are still within like their egg sac and developing.
Okay.
And then I think once they get
then they got to get out.
Then they got to get out. Now, that being said, these aren't small babies. The minimum size is 2 feet.
Oh, my. Okay.
Yeah.
I was thinking
even for an
way
18-foot shark.
No. This is typically the pups measure anywhere from 60 to 75 centimeters, which is 24 to 30 inches when they are born.
What?
The
could be like
largest, you could have up to 100 of them.
Ow.
I don't know. Yeah. So they have a lot of babies. Obviously, because they have so many, a high mortality rate is pretty much presumed, because why would you have that many babies if not all of them are going to survive?
And do they feed on each other? Do we know?
I think
I talked about that one time.
I know that can happen.
Yeah, you did.
Of shark.
I think it can, but for the most part, that might happen outside of the shark. It doesn't necessarily happen much in mom. Yeah.
Okay.
Horrifying.
Wow.
Yeah. As far as we've documented, we have not seen that behavior with these babies.
I feel like you would have fewer pups if they were eating each other.
Yeah, probably.
Yeah. So, yeah, I found out about all of these. I've had 6-gill sharks on my list for a while just because they are so ancient of a shark.
Cool.
But also the fact that they have such large litters of pups and their live births as well. Absolutely insane.
Very cool.
I will pass on that particular part of no. That feels bad. So they're really cool, and I haven't talked about sharks in a long time. And I haven't talked about the ocean in 10 weeks, so I needed to talk about the ocean.
Here we are.
Yeah. So my sources this week, Wikipedia was pretty great, but also the Florida Museum had a really awesome article all about 6-gill sharks. The Florida Museum, as well as Ocean Explorer, which was the National Atmospheric and Oceanic Administration. I'm like, I don't remember what that last number is. Sharks.org, which is shark research. Right, letter. Did I say number?
You sure did.
Oh my goodness,
Woo,
y'all.
The heat is getting to Rachel's brain.
I'm a little melty.
She's lost it.
As well as sharks.org, and then some fun little facts from factanimal.com.
Cool.
So, yeah, thanks. We're going to take a quick break, and when we return, it'll be Victoria.
Well, you all remembered that last week I talked about the dodo.
Right.
And so I'm sticking with another bird this week. And the connection I'm making here is they both have kind of disproportionate features. The dodo has little tiny stubby wings. And this week I'm talking about a bird on the other end of the size spectrum, the sword-billed hummingbird.
Oh, okay.
Oh, fun.
Yeah. Have you guys heard of the sword-billed hummingbird?
I don't think so.
There's so many species of hummingbird.
There are, yeah.
I think if you had seen a picture of this one, you would remember.
I
probably.
I feel like I've seen some that have really long bills, but go on.
Yes. So the Latin name of this species is Ensiphera, or Ensiphera. I don't know. Whatever.
Okay.
It's a hummingbird that lives in the temperate areas of the Andes Mountains. Okay. The males have beautiful emerald green feathers on their bodies and a bronzy green head, and females are, a little duller colored, as they tend to be. But of course, the most distinctive feature is its bill, which is so long that it truly looks ridiculous.
Okay.
Yes, so the length of the bird's body without the bill is 13 to 14 centimeters, or about 5 to 5.5 inches.
That is long. Whoa.
Which is a big hummingbird. It's a big hummingbird.
Yeah, I'm looking at pictures.
I'm also looking at pictures. Yeah. This is insane.
Okay,
why?
The bill on its own is 8 to 12 centimeters long.
That's longer than the hummingbird.
As long as the whole hummingbird, pretty much.
Yeah.
My goodness. Sure. Why not? Why wouldn't you?
By contrast, the world's smallest bird, the bee hummingbird, is only 6 centimeters long in total. You can fit 2 of those.
That's amazing. On the That's phenomenal.
It is the largest bill relative to body size in the entire bird world. Which, if you look at it, you're like, yeah, of course, that must be true. Truly, it's enormous. It is so long that the bird cannot preen itself with its beak the way most birds do, so it just has to use its little tiny feet to scratch itself. I just try to, I'm imagining it doing that, and it sounds sort of sad and pathetic. And also, when they perch, they have to tilt their heads upward so that they can balance, because if they tilted their head downward, they would pitch forward off the branch.
Oh my gosh.
That's hilarious. I'm not going to lie. I can imagine like little baby sword-billed hummingbirds just falling forward because they don't know how to balance. And that's amazing.
That would be something to see. Okay, so these birds do look a bit ridiculous, and the bill of that length has some downsides. Why is it that long? What are the evolutionary reasons that,
right.
This?
What do those flowers look like?
Exactly. So yes, having such a long bill means that, of course, that the sword-billed hummingbird can access nectar in flowers that are too deep for other hummingbirds to reach. Specifically, tubular and trumpet-shaped flowers. Okay. And there are many species with flowers of that shape in the area, but the swordbill seems to have co-evolved with several of them, and especially this one species of passion flower called Passiflora mixta.
Okay.
So this is to the extent where it's the passion flower's only pollinator.
Okay.
Because it is the only one whose bill is long enough to reach inside.
All right, that tracks. There it is.
Okay. So how did this occur? So there's a benefit to the bird for this. They have an exclusive food source. They don't have to compete with other hummingbirds for these flowers because no other species can access them.
Right, but why is that how is that beneficial? I mean, I'm probably thinking too linearly about it, but how is that beneficial for the flower to not be pollinated necessarily if it's only being done by one?
I didn't find like a lot of research or explanation about that, but I was thinking about it, and I think what I would guess is that when you have a coevolution like that, the flower develops in such a way that it is perfectly suited to its pollinator, so that it's probably more efficient at pollination.
Okay.
And if the species of bird is only visiting those flowers, it's not going to like take its pollen to some other flower sometimes by mistake. That's not going to do anything. Like if you have a bird that's going from, a daffodil to
a daisy, then it's not going to be able to pollinate because they're not the same flower.
Exactly.
Got it. It's a risk. Got it.
Yeah. And a lot of species of hummingbirds have to spend a lot of time and energy defending territories of flowers because nectar is a very scarce and precious resource because hummingbirds have to eat so much because their energy needs are so enormous.
Right.
And so with less competition, the sword-bills don't have to use their energy to defend in the same way.
Mm-hmm.
There's a little bit of a fly in the ointment here, which I sort of use that term with purpose.
Okay.
Nectar thieves. So
how do you thieve nectar when it goes straight in the bill, though?
Well, no, these are insects and birds that
right?
They don't go in the front door. They break in the back door.
Oh, okay.
So they go to the sepal end of the flower, so the end near where it attaches to the stem, and they drill in or bite in and steal the nectar from the nectar chamber that's at the end of the long tube without getting anywhere near the pollen.
I mean, that's bad for the flower, but that's really efficient.
Very.
Right.
Of course, that also leads to an evolutionary arms race. So these passion flowers have very thickened protective areas around the base to try to deter some of this behavior. But of course, some of the nectar thieves still get through. And in fact, there's an entire genus of birds that I never heard of before called flower piercers that live in Central and South America. Diglossa. Yeah. And they also have weird bills. So their bills are specifically adapted to drill into flowers. So if you look at them in profile, their bill is like pointing up at an angle, pretty sharp angle, and they have a little hook in the end. Sharp hook.
Huh.
Wow.
Yeah. They're
Every
also
day,
kind of goofy
nature
looking.
Astounds me.
Yes.
That's its job.
And birds are the ones that are best at piercing through the ends of flowers like that. Some insects can also drill through, but then there are a lot of insects that will take advantage of a hole that a bird drilled.
Oh, 100%.
Yeah.
Sure.
Tasty,
but then, of course,
tasty nectar.
Hummingbirds will then notice that and tend to avoid the flowers that have been robbed. So,
because they're a waste of time.
Yeah.
Mm-hmm. Which also means then that those flowers don't get seeds, and those genes don't get passed on necessarily.
Exactly, which is how you wind up with thicker and thicker protection at the base of the flower.
Ugh. Evolution right in front of your face.
Exactly. I don't have a lot more. I just thought the sword-billed hummingbird was so cool and so goofy looking. And then I found out about these cool flower piercers as well. So a bit short and sweet this week. My sources were a really interesting blog post from Fundación Ecomingo, which is an Ecuadorian nonprofit. CME Science, the American Bird Conservancy, and Wikipedia.
Awesome.
Nice.
Thanks, Victoria.
Thank you.
Absolutely. And that's all we have this week. We're going to go back to our computers and come up with some cool and weird things to share with you next week. And until then...
It's hopefully cool, not so hot.
Yes, hopefully cooler.
Enjoy some ice cream, everybody.
Yes.
Please do. Or some sorbet if you're lactose intolerant. Or risk it for the biscuit.
Or, like coconut ice cream. That's also delicious.
Ooh.
Coconut based.
Surprisingly good.
Yeah.
Anyways, bye everyone.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.